We have one of the sweetest projects in the shop right now. This is the microbus for Millie's Ice Cream Company. A great place to get an ice cream cone. And this particular microbus goes around to different venues and serves up scooped ice cream. What we're doing for them is putting a rack on back, because right now when they arrive on site, the bus is powered by a generator. And they're lifting that generator up out of the bus, bringing it around back, setting it on the ground, starting it up for power. The generator isn't a small generator, it weighs a fair bit, and so that's a lot of work that could be avoided if they had a rack back here that the generator would ride on when they're going down the road. All they would have to do is park, start up the generator, and they'll have power. So what we're going to do is attach two receiver tubes to the frame of this bus, because it has no hitch receiver back here right now. Once we have those two receivers, then we're going to build a custom generator rack that slips into those receivers, can be taken on and off, and it will hold the generator all the time. The rack gets powder coated black, should be a fun build. It's sure to be useful, and we're going to make a video out of it so you can follow along. I'm getting started by pulling the bumper off the microbus so that I can get some measurements and figure out where I want to put those two hitch receivers. I'd like to put them in the same location on each side, meaning that both sides are equal. It's going to make it easier overall. Here in Indiana, central Indiana, they put a salt on the roads when it snows to help things melt. But that salt water gets kicked up into the vehicles, causing a lot of rust and corrosion. And it was really tough to get the bumper off of here. But we succeeded despite all the rust. You can see some of it laying there on the ground. But I had to take one of the bumper mounts off with the bumper, separate it on the bench, and now I'm putting it back on the bus. After getting some measurements, I'm now cutting out my receiver tube. Most mechanical tubing, will have a seam on the inside of it that protrudes into the piece of tubing. You can feel it with your finger, see it with your eye. That's created by an electronic resistance weld. However, this piece of tube has been drawn over a mandrel to flatten that weld out so that it will not interfere with a hitch as you slide it in and out. This is specifically designed to be hitch receiver tube. There's the bracket I'm going to cut out. After doing some measurements and drawing that up in the computer, I'm going to cut out two of these because they're going to work the same on both sides. There was a little hole on the frame I found that looked like it had been made during the manufacturing process that was on both sides of the vehicle, which made it helpful because I was able to measure from that point to find an equal spot to put the receivers on both sides. There wasn't a whole lot of similarity between the sides and where to measure from, and the body panels were a little bit different. So those holes came in useful. I'll show those to you later. But now that I have those pieces of steel cut, I am attaching them to my receiver tubes in the same location. One of the sides needed spaced out about a 1/2 inch to clear. I'm figuring that out right now, and you'll see how we handle that. I'm going to take some 1/2 inch bar stock, and I'm going to cut it down. A couple pieces each side, and I will be able to attach those to the steel bracket and effectively space it off the vehicle just fine. The 1/2 inch bar stock will weld to this bracket, and then the other edge of it will weld to the frame of the vehicle. It's going to work great. Now I'm drilling some pilot holes for the hitch pins. I measured out on each side of the receiver tubes, and I'll start with a pilot hole on each side. Now I'm switching over to the drill bit for final drill. This will be the size for the hitch pin. I find it works best if you drill from both sides of the receiver tube. If you try and drill all the way through, it's going to be off a little bit on the other side. Your hitch pin's going to go through at an angle, and it's going to make it harder to line up with your insert, whatever that is, whether it's a hitch or in this case a generator rack. Now I'm going to make the rack for the actual generator, and what I like to do before I make something is just take a moment and make out a cut list of everything I need to do. That way I'm really efficient. I've thought it all through. I know all my measurements. All I have to do is cut them, assemble them, and that's it. So I'm cutting the angle frame for the actual generator rack now. And look at this. You know your saw is set up pretty good when you can do a cut both ways and get just that little remnant sticking up in the air. And it was pretty even all the way down. Most dry cut saws like this that run the carbon tooth blade, they only bevel one way. And it's usually the fence that bevels and you have to rotate the saw around the piece. This one's a little bit different. You may have noticed that. It looks like a Makita saw, and it is up top, but down low it's a DeWalt table. It is a DeWalt compound miter saw table with a Makita dry cut saw head on top. Jesse made this. We call it our Dakita. And the story that he did about it is still featured on the Brothers Fab Shop Instagram at the time we are posting this video. So if you want to see how he did that, you can check it out there. I'm getting the cross measurements on this rectangle before I put all my clamps on. You can have equal sides, like equal opposite sides. So my long sides, let's say they're both 48 inches long. But if I don't get my crisscross measurements, they may not be square to each other. One may be shifted one way and one the other. You can build a rectangle that measures equally on opposite sides, both opposite sides, and it's out of square. And that's going to make it terribly difficult, if it's not in square, to cut the expanded steel to fit the bottom, to weld on the inserts that go into the receivers, or anything else you're trying to reference off. So checking your cross measurements when you're trying to build something square and make sure it's square before you actually weld it off is incredibly important. It's going to save you so much time. It's going to look better. It's going to work better for the end user. So always do that. You can see when I'm blending this, I blend the flat surface first before I come back and address the bevel on the corner. And that is the way to do it. It's really tempting to start with the bevel because you can take off a lot of material quick. It looks like progress until you have to go back and clean up the flat sides, and then it's a whole lot more work, and you can take the bevel too far initially without realizing it if you don't have that flat side already flattened for visual reference. Now I am painting these receiver tube assemblies because it's going to be terribly rough to try and tape off and paint under the vehicle once they're welded on, and you're not going to be able to do as good a job of getting every surface. I did tape off the portions that I need to weld on, so I don't have to grind the paint off those, and that was pretty fun to peel that tape off. And now, just using some clamps, I am clamping these up to the frame of the vehicle on each side. You can see that I have the vehicle on jack stand, so it's not, I have the level on there just to compare side to side. Chances are I'm not centering the bubble. I might have it off to one side, but I'm doing about the same amount on each side. Measuring off the bumper for, visual effects, because you're going to see this generator rack in relation to the bumper, so you'd like it to be straight with that. Even if it's not quite level with the ground, if the vehicle leans to one side or the other, you'd like the, generator rack to lean with it. If that makes sense. So this is a case of, do you want it to be level or do you want it to look level? And yes, we want it to look level, but if I start, relatively level, then hopefully that's a pretty good starting point and we can tweak it from there. So I'm just barely tacking them here now. I could grab one of those and just rip it off with my bare hand with this small tack weld I did on there, but that's the way I want it. Because now I lower it down to the ground and I can manipulate those a little bit with my hands, bend them one way or another, lift them like this with a jack. I inserted a tube in there and now I'm lifting that up, adding another tack, and I'll do that on the other side, get it set up the way I want it. If you've ever heard the term measure twice, cut once, it's kind of the same philosophy right here. I'm measuring all the measurements I want, and then I'm just tacking. I'm not locking anything in with the big weld until it is exactly where I want it. Otherwise, you end up having to come and cut welds out and change things, and it just makes it a mess. So enough to hold it, not enough to permanently set it yet. So I measured between those, and I also got cross measurements under there. I don't know that I put that on film in here, but I cross measured between them to make sure they're in square with each other too, because I want it to be easy to slide this generator rack on and off. I don't know how often it'll come off, but when you do want it off, you want it off quick and easy. And now that I have it all set up the way I like it, I am doing those final welds. I was very cautious about where the fuel
is supplied to this motor. You don't want to throw a spark into the gasoline. And so I took necessary precautions to keep all the sparks away from the fuel supply, fuel source. And you can see I weld and then I check around the area, make sure all is well.
There's the weld. Jogs over 1/2 inch. Just like it does on the other side, trying to keep everything symmetrical. There's the hole on the frame that I referenced for distance. And then set the height of it off the exhaust pipe on the other side. There's a hook on the bumper that comes down right here, a tow hook. It doesn't come down as low as the exhaust pipe does. So I set the other side to be just under the exhaust and then matched it at the same height on this side. I'll show you the other side. Here's the other side. And I got that pretty close to the exhaust pipe there. You can see it's not touching. And I vibrated the pipe a bit with my hand, bounced up and down to make sure vibration isn't gonna make it come in contact, and it doesn't appear that it is.
And here's a little spoiler for you. It vibrated and touched the receiver. I get a call from the owner. He says, there's a loud rattling sound when I drive the bus. I immediately knew what would be causing a loud rattling sound while he drove the bus. I vibrated that exhaust pipe pretty good by hand and wasn't getting it to touch. So I was impressed that the motor vibrated it as much as it did and made that sound. He brought it over. We nipped the exhaust pipe off, welded it back on straight, and it fixed the problem. Now you can see we're welding the stretchers into the frame. This is going to keep the sides equidistant, and it's going to support the expanded steel, which we're going to put in there as a decking. And now here are the inserts that will hold the generator rack. And you can see that glove says SJ. That's not my glove. That's my brother's glove. That's Steven. He has been working on this project because I am working on the modern shade structure now. And you'll probably see me in the background working on the post and beam for that, which is also a video that came out. It turned out really amazing. If you like modern shade structures or any type of patio landscaping, outdoors, anything like that, you can watch that video. You probably enjoy it. It's up on the channel. There's a test. Fits great. And now we have both of the inserts in, and we are clamping the frame of the generator rack to it. We're using these big 90-degree speed squares we have to be temporary supports. And now we're very carefully slipping this out of the tube receiver so as not to tweak anything and make it change. And we're going to take it over to the bench and we're going to tack weld it. Same thing here. We're not going to weld anything off until we are very happy with where everything is at. So what we do is we tack weld these in place. Then we'll remove our squares, which are temporary supports, because the tack welds are strong enough to hold it. And then we'll go test it again. Assuming that test works out, then we will weld it off. Here we go to test it, and it worked out. So we are welding it off. Steven's doing the final welds on that. And that's me in the background working on that modern shade structure. You got to check out that video if you like that kind of thing. Now Steven's putting the gussets on the inside corners of this, and look at that nice little 3/4 inch tube stretcher we did. That goes from the corner of the insert to the bottom of the generator rack. Now those are probably not necessary, but this is a belt and suspenders type of approach. We want this thing to be plenty strong for years to come, and those are definitely going to make it less flexible for sure, and it's probably going to last a lifetime. I would rather something be overbuilt than just barely strong enough, because if it's just barely strong enough, it tends to be flimsy or easily damaged. If it is more than strong enough without adding additional bulk or weight or, distasteful design elements, then I would much rather have it that way. So that's the way we try and do it. Steven's cutting out the expanded steel for the decking on this generator rack. And there it is. Let's see if it fits. Moment of truth. Look at that. If that rack frame was not square, if I had not crisscross measured that, it could be a bit out of square, and that would not have dropped in. So you would have had to come back and mark it at an angle and trim both sides. It's just a headache. You can avoid all of that just by making sure your crisscross measurements are the same. When you're welding down expanded steel, you want to make sure you're welding it frequently enough that you don't get vibration between your weld points, because why would you want your expanded steel to vibrate? So Steven does these nice little tack welds frequently, and that'll keep it all nice and tight in there. You'll get no rattling with welding like this. Yes, it takes a little bit longer, but you're going to enjoy that for the lifetime of the product. So just take a little more time and do it right. Now you can see this has been powder coated. It looks amazing. We are doing the final install right now. And you can see we added some hooks to hook ratchet straps to tie down the generator. This came out good. Even if you mark everything out and your pin fits through before powder coat, it might not after powder coat, or something can change just a little bit and one's more snug than another. So if you do a final drill through with the same size bit as your final bit, and you just drill all the way through everything while it's there together, your pin will slide beautifully. Look at that, like butter. And now those holes in the back, you see right there, we're gonna put some nut certs into them. Those are stainless steel nut certs. We got some 1/4 screws, gave those to the owner. Now he can move his license plate off the back of the bus onto the generator rack so that it can be seen even while he's got the generator on there. With the generator outside, secured on this strong rack on the back of the bus, he can run the generator while he goes down the road, which means he can also run his portable AC while he goes down the road, which means that the whole inside of the van is going to be cooled. That is going to be awesome. We get a lot of unique jobs that come in, being a welding and fabrication job shop, and sometimes you don't know what's going to be next. If you like this kind of thing and you want to see what that next job is, make sure that you're subscribed so that you get the video about that too.